Well, good afternoon, and thank you very much for being here at Fayetteville Public Access Television for our monthly workshop. I'm Dan Robinson, the Executive Director of Your Media. Your Media is the service provider for Fayetteville Public Access Television. We provide the services for the city of Fayetteville and are happy to have the opportunity to share these wonderful resources with the Fayetteville community. So the workshop today is Introduction to Audio, how to make things sound great, which is very important. Audio is one of the key parts of a lot of things that we do. And I wanted to start off by giving you an introduction of how I came to fall in love with audio. My parents got me a Fisher-Price tape recorder when I was like 6. And so the whole concept of being able to record what I wanted and then play it back to me was just enthralling. And I instantly got into doing things like sound effects, like crinkling plastic to make it sound like fire and telling stories, and then started playing with slowing down the tape and all the things that you can do that you aren't really supposed to do with a tape machine to try to make cool sounds. So I was intrigued right out of the gate. And then at 15, I started running sound at church, which is where people most often have to step in to assist. Churches very often have a very difficult time with making things sound good. And so when I had the opportunity to start running sound, it was actually at church. And that was an instant way that I found that learning about sound was a way that I could help those around me. Then I studied music technology at Kansas City, Kansas Community College from 94 to 96. And then in 1995, I started a recording studio where I started charging for my services. I was able to start making money with the skills that I had learned. And then at Kansas City, Kansas Community College, I had a really interesting opportunity because when I arrived there, they did not have a music technology department to speak of, but they were developing it. And so I was able to work with my professors essentially with a blank purchase order and a catalog. They were like, what do we want to have a music technology department? And so I was able to really kind of build with them from the ground up the equipment that was necessary to have a recording studio. And with that knowledge, I went out and began working as a recording engineer in Kansas City, essentially making beats for hip hop artists. Because I was a composer, there were lots of hip hop artists that wanted stuff produced. I was able to produce the beat for them and record. So they were able to get an engineer and a beat producer. And I was able to do it really cheap because I was in college. So I produced lots of urban hip hop between 94 and like 98. And I've been working as a recording engineer ever since for bands. And I have a recording studio. I worked as a sound engineer at George's Majestic Lounge from 2002 to 2008. And I was the production manager there from 06 to 08. And that was an amazing opportunity to work with national artists and really flexed my whole set of skills as far as audio production in general, because those are extensive audio productions that they put on at George's. So it was really exciting to be part of that team. And then I have a recording studio here in Fayetteville called The Foundry. That's a 900 square foot space. It's got 4 isolation booths. It's 30 feet away from my house. So I'm able to, I call it my 15 steps of joy. I'm home in 15 steps, and then I'm at work in 15 steps. And there I'm able to record the material I need and then also do video production at my studio. So why learn about sound? Basic applications of sound engineering. First and foremost, what got me started was sound at church. It's a great opportunity to be able to help people make things sound better, because it's so often a challenge to be able to make things sound good in a church environment. Also sound at an event. If you have a community event, someone's giving a speech, you have some sort of rally, so often they rely on volunteers to provide sound equipment, and then people don't know how to operate the sound equipment. And the goal of this class today is to give you a basic knowledge of how you could step in a circumstance like that and help them get things sounding good. And then audio for video, which is another thing that I think will specifically apply to you guys and be a great opportunity. Audio for video is a unique animal. It's a little bit different, but a lot of the principles that we discussed today will apply to that as well. Audio for video usually looks like this, right? You got a guy with a boom pole, and we'll talk about why that is happening later on as we discuss this. When you're doing audio to video, especially on location, there are 2 routes you can go that I wanted to bring to your attention just so that you can know. One would be direct to tape. That's when, for instance, this microphone would be plugged in directly to the camera, and then the camera would be recording the audio that comes from the microphone. And the goal of the boom is to get the microphone as close to the subject as possible while keeping the microphone out of the frame. So direct to tape is one option, and then an external audio recorder is another option, where you would have a separate device that would be recording the audio, and then in post-production you would put those two together. You would sync up the audio and the video. So next, the basic philosophies of sound. Sound can be a very intimidating thing in that it seems like something that's very hard to control. There's lots of random factors. And my goal is that with these very basic ideas, it will help make it feel much more accessible. So these are things to think about as we move forward. The primary goal with sound in general is that we make it sound good, right? But the problem is, good is relative. So what is good? What someone thinks, what sounds good to someone may not sound good to someone else, and vice versa. So the question is, what is good? Good, I would say, for our purposes, is natural. The goal is that you want it to sound natural, as if you were there in the space. As we are transferring sound into electrical signals, we want what we capture to represent what is actually happening in the space. So that will define good as natural. And then what we're going to be talking about today are the ways that we can get the most natural sounding sound possible. A very important thing that we will talk about all through this is you don't want to do anything you don't have to. The more stuff you do with the different tools that you have to do things, the more different the sound will be than it was originally. And so very often people want to try to fix the way things sound, but then the moment you start doing things, you're stepping away from natural and stepping into manipulated. And so it's good when you need to. If you need to fix things, it's great to have those tools, but you don't want to do anything you don't have to. Louder is not better, even though it seems like it would be, especially in live circumstances. The goal is to make it loud enough. You want it to be loud enough to be healthy tone, but you don't want it to be too loud. So we will discuss here in a bit about keeping the levels nice and healthy. And then, finally, be aware of your own hearing. Everyone has a unique set of ears, and it's good to know what yours are capable of. If you have the opportunity to get a hearing test and find out what your hearing response is, that's great. You know, everyone's ears are different. I always kind of joke that you shouldn't trust a sound guy with small ears. And I found, you know, that the thing that got me teased all through grade school when I became a professional sound engineer became a huge asset, in that, you know, having big ears as a sound guy is kind of like having long legs as a basketball player, especially when it comes to proximity. What I can hear is kind of distances of things as well when you kind of are listening for that. So there's lots of, but everyone's ears are different. You want to be careful about sounds that are too loud, obviously. And you want to protect your hearing, but you want to be aware of some people have pockets of frequencies that they just can't hear. So you want to be aware of how you hear personally. So now we will get into the basics of sound. First and foremost, sound is vibration. It moves through the air. It reflects off of things. It's absorbed by things. It's kind of a living thing. Things create these vibrations, and then the vibrations are bouncing around. Vibration is essentially a wave. The wider the wave, the lower the frequency, the lower the pitch in musical terms, like low notes. And then the tighter the wave, the higher the frequency, and the higher the pitch. Here's a diagram that illustrates that. So low frequencies are the ones you can feel, right? When you're at a concert, there's lots of they're woofers, They've got lots of 18-inch speakers that are pushing low megahertz. You can physically feel it in your body when they're moving that much air. And then with higher frequencies, it just gets really shrill and intense. So it's good to be aware of what vibrations you're working with. Then what we're doing is converting these waves into electric signals. We've got the vibrations that are waves, and then we want to translate those to an electronic device for two purposes: for recording and for amplification. If we want to make them louder at an event, or if we want to record them, like for audio for video. And this is a diagram of a waveform in a digital audio workstation. When we look at digital audio, that's what it tends to look like. So then the tools of sound to capture these things. We're going to need more paper. You guys are taking great notes.
Combine a little bit, summarize a little bit.
The tools of sound would be microphones, is the very first step to capturing these waves. And so it's very important to know how they work and why they work. They capture the sound and translate it into an electrical signal. This is an example of a condenser microphone, kind of fancy studio condenser microphone. To understand how microphones work, what you want to know are the basic parts of a microphone. There are, of course, lots and lots of parts of lots and lots of different types of microphones, but the parts that really matter that you want to be aware of as you're using microphones are the diaphragm in particular. You've got the diaphragm, the magnet, and the coil. And the thing that's really important is the diaphragm. The diaphragm is a thin sheet of usually metal, but it can be any number of things. And it is the thing that vibrates when the waves hit it. And then the coil, along with the magnet connected to the wire, translate the vibration that the diaphragm gets into an electronic signal. And so the thing you want to be aware of is how hard is your diaphragm working? Is it working very hard, or is it not working? Is it sitting there waiting to get vibrations and having a hard time being reached by the vibrations? So you can see in the diagram, the sound waves hit the diaphragm works with the coil and the magnet, and then you've got the wire that translates that sound through the cable. So the trick is to use the right kind of microphone for the application. So we'll talk about basic types of microphones that you would want to be aware of. First is the condenser microphone, and which looks like this very often. Condenser microphones are designed to get a flat, neutral sound. The goal is to make things sound as natural as possible. They very often require what's called phantom power. Because of the nature of the microphone, it needs an additional little bit of voltage to be as sensitive as it needs to be to get all of the things in the room, which is what the condenser microphone is trying to do, is just capture every sound wave that's happening in the room. So you'll see a plus 48 sometimes on a camera or on a mixing console. And you would select that if you're using a condenser microphone, and that powers the microphone so that it can pick up those very small signals. Then you have dynamic microphones, which you very often see rock stars holding, good old vocal microphones. Those are designed to deal with things that have a wide dynamic range, that go from quiet to loud, with the emphasis essentially being on being able to handle loud. Because obviously, when you have lots of sound, if something is very loud, then the diaphragm of the microphone has a hard time translating that information. So if you have a microphone that's designed to handle that, then you're able to get a much better sound. Proximity is also very important. Dynamic microphones are designed to be close to their subject. And they specialize for vocals and instruments, and you get those really close. Whereas with a condenser microphone, you can get it close, but it doesn't necessarily have to be close. Most often with condenser microphones, you use a pair of them, and you essentially, they simulate your left and right ear. And so with condenser microphones, you'll use them, you'll kind of set them in a spread, and they'll be and then you'll have a left and right signal, and that will go to your respective ears. Whereas a dynamic microphone is usually one signal coming from one instrument or one vocal, and is usually, and once again, is designed to handle a wide dynamic range of volume between quiet and loud. And then you have specialty microphones, of which there are a million. Microphones that are designed for a specific purpose, like a kick drum microphone, which is a large diaphragm microphone. It has a bigger diaphragm so that it can catch those large waves as they're coming out of the low frequencies. And so anything that is a lower instrument, you would want to use a larger diaphragm microphone. And then you have something like this, which is essentially a condenser, but that is specialized to act like a dynamic with a saxophone, and is designed to be clipped right to the bell of the instrument. And then you also have ribbon microphones, which set up the relationship of the diaphragm and I mean, just the way the microphone works is different, so that you can end up with kind of cool patterns like that one, where you're recording in front and in back of the microphone at the same time. So the question that is important is, what is your mic doing? The first thing to know is, what is it picking up? What are you miking? And then what you want to do is pick a microphone that fits the application. If you're trying to record a whole rock band with a condenser mic, it's not going to work. And if you're trying to record something like something where, for instance, a string ensemble, if you had a string ensemble in a space and you had a dynamic microphone sitting in front of them, it wouldn't do a lot of good, because the dynamic microphone needs to be close to the subject. So you want to pick a microphone that matches the application. You want to be aware of the microphone's color and its limitations. And by color, we don't mean gray, black, or blue, but instead how it makes the sound, how it shapes the sound. Sound people very often use, we use lots of different adjectives, just like very often we use onomatopoeias too, to describe how things sound. So, you know, when you have a darker sound or a brighter sound, very common terms. Darker having less high frequencies, brighter having lots of high frequencies. So some microphones are more sensitive to higher frequencies and not sensitive to lower frequencies, and so it would have a brighter color. Whereas something that was large diaphragm may not be as sensitive to the higher frequencies, so it would have a darker color. And then, of course, there are microphone specialists that make all sorts of different microphones to have specific colors to help shape the way it works. And then this is an example of a cardioid microphone, a cardioid pattern. As you can see, with the bottom of the heart, right, looks like an upside down heart, which is why they call it a cardioid pattern. At the bottom of the heart is where the microphone would be. So it picks up the stuff that's just right around it, and then the stuff that's in front of it, which is great, because if you've got something behind it that you don't want picked up, this microphone is pretty directional, right? It would only pick up the stuff in front of it. So this is a cardioid pattern from a dynamic handheld microphone, which, if you think about it, the artist has floor monitors in front of them that help them hear the sound, and the back of the microphone is to the floor monitor, which is kicking them their sound. So it's designed to ignore the sound behind it to prevent feedback. So different microphones have different pickup patterns like this, and you want to make sure that you're aware of the pickup pattern of the microphone you're using, so that you make sure that you're getting the sound that you want, and you can actually use it to avoid the sound you don't. For if you're in a crowded place and you're trying to get an interview, a dynamic microphone with a cardioid pattern will be great, because the person will be speaking in their microphone, and then the crowd noise around them won't be nearly as audible. If you were using a condenser microphone, you would hear all the noise from the room and the person speaking. It would be hard to differentiate. Then the next thing is cables. And when I've been to previous sound things, they very often skip Or when someone's explaining to you about sound, they say, you plug it in with, you just plug it in. And they don't talk to you about what kind of cables you're going to run into. And so I wanted to cover just a basic several types of cables that when you're running audio, you're going to run into and what their purposes are. You can't skip over cables because if you do, you end up like this guy, just not knowing what you are supposed to use. So there are basic types and purposes. The first two types I want to just make you aware of are signal cables, which are designed to carry sound and electric information, but not a powered signal, like from a power amp. A power amp amplifies the signal to be pushed through loudspeakers. And there are cables specifically designed to carry that amp load, and there are cables that are not. So a signal cable should not be plugged into an amplifier going to a speaker. It will connect two things that are not pushing amplified power. Speaker cables are designed to carry the sound amplified to a speaker to push the speaker. So speaker cables are most often labeled. You can look right on the cable and it'll have lots of little numbers and then it'll say speaker cable. And so you want to make sure, and you don't want to use a signal cable for a speaker cable because it's not good for the power amp or for the speaker. Signal cables. We have XLR, which is a very common kind of cable for microphones, very often referred to as a microphone cable. It's a 3-prong cable, carries a hot, a cold, and a neutral or a ground. Then you have a 1/4-inch cable, which is very often referred to as an instrument cable. So an XLR is a mic cable, usually plugged into a microphone. A 1/4-inch cable is usually an instrument cable being plugged into a guitar or a keyboard or something along those lines. 1/4-inch cables also come in balanced. And I don't know if you can see, it's really small up there, but in this case, the 1/4-inch cable has one black line. The balanced one that's underneath has 2 little black lines. And so then that cable is split into 3. Then it's able to carry 3 wires instead of 2. The 1/4-inch cable has a tip and a ring. The balanced one has a tip, ring, and sleeve. So you have 3 signals that are being carried on the one cable, on a balanced 1/4-inch cable. RCA cables are the kind of cables that come with your DVD player, or that used to come with your DVD player back in the old days when we had DVDs. And then now with Blu-rays, it's all HDMI, which carries your audio and video all at the same time. Before that, we had RCA, which is still a very common form where the yellow is video and then the left and right audio are the white and the red. So here you've got video and 2 channels of audio. Then sometimes you'll see these RCA cables in RGB, which is also referred to as a component out. And that's literally like red, green, and blue for when, once again, back in the day, when they would split it into those 3 channels to be able to translate the signal, that was how the component out worked. That carried video with no audio at all. Those were just the 3 video signals. And then a very common one these days is 1/8-inch or mini plug, which looks like this, headphone plug, right? And it's got 2 little rings on it usually, right? Which gives you the left and the right. And then as we smartphone users know, then if it's got 3 prongs, then you've got left, right, and a microphone, right? So that when you're using your headset that has a microphone, it's got 3 prongs. Sometimes you'll see mini plugs with 4 little rings that's giving you video and audio with a microphone. They make all sorts of different variations. But the thing to look at on cables is, especially on cables like this, is the number of rings, because that will let you know what the application of the cable is. Then, once we've gone from the microphones to the cables, the next location that we're going is the preamp. It is the sound translator. It's kind of the destination of the sound. It provides the gain, which is a very important thing. Gain structure is really one of the most important aspects of capturing sound. it sends the signal to its destination. Once it has come in, the sound has come in through the preamp, it does what it does, and then it sends the signal out to wherever it needs to go. Very often in these days, the preamp will do the analog to digital conversion, A to D conversion. So that's very important to know how long your signal is analog and when it becomes digital. Because when it becomes digital, it becomes ones and zeros. And the nature of how the equipment changes, how the equipment works changes. In analog world, you're sending signals through physical things, and the physical nature of the things color the sound. Very often they have tube preamps are used in recording studios. And so you plug your microphone into this tube preamp, and then it does something magical with these tubes that makes it sound warm and rich, and it saturates the tube with the signal and then outputs this beautiful, wonderful signal. And that's all in analog land. Then it goes through an A to D converter, which changes it into ones and zeros, and then it's like a digital photograph. From that point on, there's no more creative coloring unless you're doing it in post-production, unless you're changing it with effects. But once it's digital, it's firm. And the reason that I want to emphasize that is when you're doing your A to D conversion, it's really important that your signal be healthy, that you be in the green and maybe flickering the yellow, which we're going to talk about here in a bit. But if you take an analog signal to red, sometimes you can get some fun, interesting things. If you take a digital signal to red, you're just getting clipping nastiness. So you don't want to play with the red with digital signals. So it's good to know when your signal is being converted into digital. Which, when you're doing audio for video, like what you guys are talking about doing, that conversion happens right on the camera. It is going to be converting it from an analog signal into a digital signal right there at the camera. And then if you're in a recording studio environment, then it happens somewhere in the process before it goes into the computer. The mixing console is the ultimate preamp source. It gives you the most control over your sound. When you're doing direct to tape, then you don't have a mixing console in between. You can. I have done movie shoots where we plugged microphones into a mixer, and then we went out of the mixer into the camera. So we were able to have all the tricks necessary for a mixing console, but then we didn't have to have an external recording device to capture the audio. But when we see mixing consoles, it very often looks and feels like this. Like, oh my dear God, there's like 6 trillion knobs. And the interesting thing is that it's just remarkably redundant. It's all the same thing. It's, in this case, you're looking at these batches of 16 channels, there's 24, but they're all the same thing vertically. And we're going to talk about what those are. This is the breakdown of what that is. Each one of these is an individual channel, and they're all the same thing. But this way you can have multiple things and mix them all together. So at the top, you have the gain knob, which is very important. That's where we're setting up our gain structure, which I'm going to talk about here in a minute. It's really important. But that decides how loud the signal is coming in to the preamp. Then you have your EQ section, which is where you can manipulate the sound if you need to. It allows you to modify the sound by frequency. This is the don't touch unless you have to zone. Because the moment you start messing with EQ, you start coloring the sound. And you've stepped away from natural and stepped into modified sound. Then you have the auxiliary section, and then also the assign buttons below are the routing. They decide where the sound is going once you have brought it in and once you have colored it. Then it assigns where the sound is going to go. And then the faders are the ultimate destination, which decide how much sound is going out once you have done all this stuff. So that is the basics. When you look at a soundboard, when most people panic and say, I don't even know what this stuff is, at the top you're deciding how loud it's coming in, then you decide how it's colored, and then you decide where it's going and how loud it's going out. It's 4 things. Very easy. Most importantly of all of those is the gain structure. You want to watch out for headroom. Headroom is essentially the term for everything that you're not trying to record. when you have your microphone on, you have the thing that you're trying to record, and then there's other stuff. Or if your signal that you're recording, if your gain is very low, then the thing that is being recorded to is looking for lots of signal, and there's going to be hiss. You know how on some recordings you'll have like hiss that sounds like something's turned way up, and it sounds like if something loud happens, it's going to go pow. That is the headroom. That is the signal that you don't want. And the way that you can avoid that is by making sure that your microphones are the right distance away from your subject so that you're not picking up a bunch of stuff you don't want to. And you want to make sure that your gain structure is correct, that you're pulling the sound at the right level, and then when it's coming into the channel, and then when you're sending it out at the right level as well. Something I'll talk about more here in a bit, but I'll go ahead and mention now is the rule of sevens. Anytime you have a level that you can select on something, anything from a headphone volume to an input gain, anything like that, 7 is good. 10 being the loudest, 1 being the quietest. It's a little louder than halfway, not quite all the way loud. It gives you a good, healthy input. Now, in some circumstances where, especially if you have a loud instrument, you'll have to back that off. You'll have to break that rule. But in a general circumstance, 7 is a great place to start to try to figure out where you need to go from there. Things that help with headroom are compressors and limiters. And the reason I wanted to talk about compressors and limiters, I could do a whole seminar just on them, but the reason that I wanted to bring them up today is because very often cameras have them built in, and you want to be aware that your sound is being compressed. The summary of compression is when you have a loud signal coming up, a compressor will then, at a given ratio, push the sound back down depending on how hard it is coming up against, with the goal being that your quiet sounds will be as full as your loud sounds. Because as the sounds get louder, the compressor with the ratio is pushing down accordingly. The goal is that you don't hear a compressor working. If you hear it squishing the sound, the compressor is working too hard. The goal is that it just feels very natural, even though it may go from a whisper to a shout, your level still stays in the green and maybe flickers yellow. So that's what a compressor does. A limiter sticks a ceiling on it and says that's as loud as it's going. And then when your loud sound hits it, it just gets squished. And that's all you get. So a compressor is a more dynamic thing. You can decide how hard the compressor is going to push against the loud sound, whereas a limiter puts a permanent ceiling on it and says, that's it. So there are different applications for both. In cameras, very often you'll have light compression or some form of limiting that will try to help you not blow out your audio. But you want to make sure to be aware whether or not there is, sometimes it'll say there will be a general setting like compression, and it'll say on or off. And you want to be, if it's on, you want to know how much it's compressing. And if it's compressing more than you want, then you want to turn it off and deal with your compression later on. That's compressors and limiters. You want to keep it in the healthy green with a flicker in the orange. Here we have a digital VU meter that, like you would see in any sort of digital audio workstation, and also reflective of what you would see very much with the green and the yellow and the red on a camera. What you want is to stay in the green, and then you see that top line is flickering the orange. So when the loudest thing occurs, you want that orange flicker. So when you hit the red, like the bottom one, and very often if you're looking at a stereo signal, which is what we're looking at, the top one is left and the bottom one is right. So as you can see in the right channel, they have peaked into red. And that means that the sound that you're going to be getting in the end is not going to be a good, healthy sound. It's not going to be a good representation of what you're trying to get. So what you want is the top line, which is just a flicker of yellow or orange at your loudest point. Next, after you've got good, healthy gain structure, you know that you're getting things in the green, they're not getting too loud. The next thing you have is EQ, which is very often low, medium, and high, right? You'll see that on mixing consoles, but you also see that on your car stereo, right? So they're there to help only if needed. Here you have a 31 band EQ, which is the most extensive kind of EQ that you would use. And I wanted to take just a moment and talk about lows, mids, and highs. What it's illustrating here is 20 hertz to 20 kilohertz. So that's the range over those 31 bands. And I can tell you 20 to 60 sounds really low and rumbly. And then you've got all this mid-range stuff that sounds kind of honky. And then you've got the high-range stuff that sounds like S's and T's. It's all the high end. And so if you have a circumstance where you have, for instance, a microphone has a particular color that is particularly bright, then you would want to find the frequency where it is bright. And the way you do that is by spiking them. You just go along the line and turn them up. And the one that sounds like the one that is incredibly obnoxious, then you roll that one back a little bit. And that way you know you've gotten the frequency that you were having difficulty with. You can do this digitally in a computer. There are also outboard units that allow you to do this. But the thing to be aware of is the lows, which are on the left, the mids, and the highs, and knowing which things to manipulate only if you are needing to. So once we've gone through all that stuff, we've gone through microphones, how we're getting the sound, through the cable, through the preamp mixer, and into monitoring land. The question is, what are you listening through? Because it's important. You are gauging your audio signal based on what you're hearing. And so if you're doing audio for video and you're on location, very often what you're going to be listening through is headphones. And so you want to be aware of several things with headphones. Number one, the EQ response. This is the EQ curve of most headphones. You can see big old drop off in the low end, right? It's got this weird spike there at the top and then a roll up, a real hard roll off at the top. That is not a flat EQ response. So you want to be aware that you might be getting low frequencies that you're not hearing because your headphones are not capable. The other thing is other noise. Most headphones, even closed back headphones, are not isolation headphones. And when I'm on location for video for audio, I use isolation headphones specifically, which give you a 30 decibel cut. It's like the kind of ear cups that you wear when you go shooting. But inside is your mix, where you've got your sound. So you've got a 30 decibel cut on the outside, so you're not hearing the outside. You're simply hearing what the either camera is hearing or what the recording device is hearing. So you want to be aware of those two things. And then finally, your headphone volume. So you could have really healthy green signal on your VU meter. Looks like it's coming in through the microphone, going through your preamp. Everything's looking good. And you can't hear it on your headphones. Like, what is the problem? It's your headphone volume. So I have done that to myself so many times that I will speak of it freely, where I panicked because I couldn't hear and figured out that it was simply the headphone volume. Conversely, if your headphone volume is on 10 and your signal is really low, you might be hearing, number one, lots of hiss, and number two, you're not hearing a good representation of what's coming in. So you want to be really aware, and once again, use the rule of sevens. Put your headphone volume on 7 and then see how things are feeling. And then if you need to roll it off a little bit, you can. If you have to bring it up, you can. But once you're pushing things past that level, then they're going to start straining. And when they start straining, you're not getting an accurate representation of what you're looking for. So on location, you were using headphones, then you get it back to the editing bay and you're listening to it on speakers or monitors, which they're also very often referred to. For live sound, also, the destination is the speakers. And so it's really important. There are many types of speakers. Here we have a beautiful pair of JBL studio monitors. As you can see, they have VU meters built into the bottom. These particular monitors have a feature where you can plug in an RTA, real-time analysis microphone in the room, because when you're talking about speakers, you have to think about the room. You take this microphone, you set it in the room, the speaker makes a bunch of noise, and it calibrates itself to sound as flat as possible in the room based on the characteristics of the room. It's a smart speaker. It's a whole lot of fun. The goal with speakers and monitors is to get a true transparent sound. Things to be aware of: the coloring of the speakers. Check out the EQ frequency response on a set of speakers. Way different than the headphones, huh? That is flat. You can see it rolls off at the low frequencies. I can tell you 20 hertz to 40, 60 hertz is like the speaker doing this. I mean, you don't even really hear it. So they will roll off at that point. And then you see at the top, there's a slight roll off as well. But the goal is that the frequency response of what you're listening through be very flat. And that gives you an accurate representation of what you're listening to. The other thing to be aware of is the room you are in. Every room has a frequency that it resonates at. There is a sympathetic frequency in any space. You will learn as if you study acoustics. You want to be aware of that sympathetic frequency, because sometimes you will end up with things that sound great in the room that you're in, but then you take it somewhere else and it sounds terrible. And you're like, it sounded great at home on my speakers. Why doesn't it sound great now? The room that you were in was unnaturally absorbing bass frequencies or high frequencies. There was a lot of bounce around, so you kept it really low. There are lots of different things about the room that change the way that you manipulate the sound. So it's good to be aware of the room that you're in when you're mixing and listening to your final product. So, as kind of an overview of what we discussed, sound is a natural force. So you want to take those factors into consideration, the natural elements around you. The room, the microphone, what is making the sound, what kind of mic you're using, and where you're putting it, what kind of room you're in, and how much of that you want to get into the microphone. And then what is the destination? Is it going to speakers for amplification? Is it going to a camera to be recorded? Where is it ending up? And where it's ending up, you want to make sure you're getting healthy levels. Good gain structure is so important. Can't emphasize that enough. That is where you make or break your audio track, is whether or not you've got a healthy signal. Not too loud, not too quiet. You want to use the right microphone to make sure that you're getting the good gain structure and the headphone. And you want a mic as close as necessary, not as close as possible, because sometimes that's not always the best application. If you've got something huge, you can back the mics off if that's giving you the most natural sound possible. The magic rule of 7. When you're wondering where to start your levels, start them at about 75%. Start them on 7, and then take them up or down as you need to. But that's a good place to start. Test your subject loud. As when I was doing my microphone test to get started, I tried to speak at a level that would be my loudest speaking level. In audio land, when we're running sound for bands, we refer to it as sandbagging. When they go, check 1, 2, check 1, 2, check 1, 2. And then they start singing, and they're huge. And we've calibrated all of our equipment, and then they want us to calibrate our equipment to make them happy. They want to be able to hear themselves in their monitors. They're like, check 1, 2, check 1. I can't hear myself. Check 1, 2, check. I can't hear myself. So you turn them way up in the monitor, then bam, they start singing, and it's way louder. They're yelling in the microphone. They're doing all this stuff. You want to watch out for sandbagging when you are checking your audio levels. If it's someone who's giving a presentation like this, if it's someone that you're doing an interview with, whatever especially when you're recording a band, you want to make sure that they are rocking it as loud as they're going to rock it. Set your levels there for your healthy gain structure, and then you will have a successful audio experience. And then finally, take your listening into consideration. What are you listening with? Headphones, monitors, PA speakers? Where are you listening? Because the room or the space that you're in, if you're outdoors, that's going to change everything, because the sound goes and it's gone. So it's a very different environment. Take your environment into consideration as you're making your audio decisions. And then know your own hearing. Be aware of your own limitations, the characteristics of your own hearing. So I hope that these basic introductory tools give you guys a great launching point as you move forward with audio production. And I really want to thank you for your attention and for the opportunity to present here at Fayetteville Public Access Television on behalf of your media. Thank you very much.